All right. Ashley, Sir Key. Of course it works. Sir K. Come on. Not Ashley. For all of these questions, this is just scratching the surface of what I can do with parallel plates. And again, the analogy I've been trying to give you is that I really visualize traveling between two plates as the mathematical equivalent of lifting an object up and letting it fall and calculating it all with conservation of energy, G. Okay? So what's the magnitude and direction of the electric field? Electric field between plates is the change in voltage divided by the distance. And now you can see why we really always write the change in voltage. Because if I look at this, what's the change in voltage? Not 500. 750. Divided by 0.055. And I got to be honest, this question to me is too easy for a written question. But as a multiple choice question, this would be fair game. But what you'll always have as well is I will give you that distance as well, just to see if I can trip you up. If you're working through the ultimate review, you'll notice every single question with parallel plates, almost all of them, give you the length of the plates if they're multiple choice, because that gives me another distance that I can use and get a wrong answer. So just don't fall for that trick. It's going to be 750 divided by 0.055. Why am I writing it twice when I already wrote it, Mr. Duke? I'm going straight to my calculator. Do you get 13,000? Yuck. 13,630. That there? 13,600 volts per meter, I would accept. Newtons per coulomb, I would accept. Direction. Which way would a positive sitting there want to move if it could? Down. I would take south as well. If I'm marking this, I would give you half mark. Half mark, half mark for the magnitude, half mark for the direction. If you didn't read this carefully and you just said that the voltage was 500, or if you said the voltage was 250 because you did sloppy math instead of going winner minus loser, or final minus initial, which means minus minus, which is plus, I would give you 1.5 if you did all the calculations correctly and just had that number wrong. I'm saying that because someone I helped earlier today did that, and I didn't tell them, and I'm feeling guilty. I can't remember who it was, but I just know someone did. Same question B. Suppose an electron is placed at location A. By the way, for all of these, for part A, I would have no problem, for example, telling you the electric field, telling you the voltage, and saying how far apart do the plates need to be for this to work? Or telling you the electric field, telling you how far apart the plates were, and saying how many volts do we need to get that electric field? Or, because electric field also appears in my force equation, F equals QE, I could say I need a force of thus and such on a charge of this. How big does the voltage need to be? So I can also replace this E with F over Q. Right? Mixing and matching. Suppose an electron is placed at location A. What will its final speed be when it hits location B at the top? An electron will fall up relative to us in this case. So as far as I'm concerned, this is very, very similar to dropping an object. I'm going to solve this with conservation of energy, G. It says placed, which suggests it starts at rest. And when it gets to the far side, it will have used up all of its potential energy because it's hit the ground, or what I'm calling the ground. So I'm going to get QV equals a half mv squared. I'm going to get V equals 2 times Q times V over m square root. Or instead of multiplying by 2, you could also divide by point. Same diff. I just don't like having a decimal inside of a fraction. To me, that's bad math manners. It's going to be 2Q. So it's an electron. What's the charge on an electron? 1.6. Am I going to put the negative in this particular situation? I'm square rooting. I want it all to be positive. If it was a proton, what's the charge on a proton? Positive. If it was a neutron, it's not going to feel force. Otherwise, I'd have to tell you the charge. As always, once you get to this line, I would also have no problem, for example, telling you how fast the object was traveling, telling you its charge, and saying, what's the mass of this mystery particle? Or telling you how fast it was traveling, giving you the voltage and the mass, and saying, what's the charge on this mystery particle? As always, Matt, we can always go backwards once I get to a certain point. Yes? This is going to be 1.6 times 10 to the negative 19, 750 volts, divided by, it's an electron. What's the mass of a proton? So just as a thought question, suppose I started a proton there and an electron there, and I let them both go at the same time. Which would hit the other side first? Well, I guess really what I'm saying is, which one travels faster? Pardon me? They both have the same amount of energy, but in the proton equation, the half mv squared, there's more m, so less left over for the v squared. They both would have the same amount of ke, though. They would, absolutely. If we plug these in, what'd you get? No one? Okay. Wow, come on. There we go. Negative 19 times 750 divided by 9.11 times 10 to negative 31. I freak out. This is faster than light. And then I say, oh yeah, wait a minute, we're okay. Do you get 1.6 times 10 to the 7th? 1.62 times... I need a nod or two? I see one nod. That's not enough to convince me.
Yes.
Seeing a lot of people didn't do the quiz. Uh-oh.
Mr. Dude,
Yo.
if a positive plate was up here and an electron went up relative to us, wouldn't gravity play a part in its speed?
Can you hold that question? That's a brilliant question. In fact, I'm going to be answering that in a little bit. Thank you, Kev. To the 7 meters per second. Let me remind me at the end of the quiz, okay? Oh, heck, you know what? Let's even do it right now. We'll pause the quiz for a second. So, I guess what you're saying is this. Electronics types don't take the force of gravity into account when calculating the trajectories of electrons. For example, in cathode ray tubes, we were going in a straight line even though gravity was pulling down. Why not? Yeah. The mass is so ridiculously light, you can crunch the numbers. The short distance that they're traveling, well, I think this even goes into more detail. Even in the Stanford linear accelerator, where the electrons travel 2 miles, because they go so fast, they only drop a few atomic diameters. It's negligible. No, it's a good question, though. I was waiting for somebody to kind of ask. I had this queued up, ready to go. Thank you. There you go. You could have thought an intelligent... Never mind. Never.
Just trying to shave some.
It's not my role, Mr. Dewick. I'm an athlete. Okay.
Trying to shave some strokes off my game.
Just be happy if you... Suppose an electron is traveling at an initial speed of that. So in this case, now, what? We have some initial kinetic energy. If you want the gravitational analogy, this would be like leaning over a cliff from a height and instead of dropping the ball, throwing it down so it has some kinetic energy to begin with, and then also all the potential energy will turn into kinetic. What are you going to hit the ground at? So I'm going to start out going KE initial, PE initial equals KE final plus PE final. By the way, what if this was negative 150 volts? What would happen to its speed for the electron? It would actually decrease. There's a question in your ultimate review where they give you a whole bunch of plates in a row, and it's either an electron or a proton, and it's slowing down, and they ask you which region would it come to a stop. you would let V final be what? 0, and you can solve for the voltage required and figure out in which region that would happen. Yeah, you can also not just accelerate particles, you can slow down particles. We got a lot of control over subatomic particles now with parallel plates. Here, kinetic energy, or sorry, potential energy final is 0, because once we get to there, we've used it all up. We have a half m v initial squared plus mg, no, q v, that equals a half m v final squared. This is right around my threshold of getting stuff by itself. Kevin, I think I would do, was that a question?
Yeah, is it alright if I, instead of putting the two halves, just make the QV times the...
Absolutely. This is the same question, the same equation. V initial squared plus 2qv equals mv final squared. So you did this. I'll do it that way because I think the last time in the notes I actually divided by 0.5 m. Here, we'll clear it out. Sure. And then to get the v by itself, I'll be honest, that's what I would do. But I don't want to scare you too much with fractions, so okay. Sure, we'll do it your way. We'll get the same answer. We'll get v final is going to be m. Was it electron or proton? Electron. V initial, 2.1 times 10 to the 5th squared plus 2, 1.6 times 10 to the negative 19. V was 150 volts divided by 9.11 times 10 to the negative 31. Yeah, let's try typing this in one fell swoop. 9.11 times Mr. Dewick, scientific notation, negative 31 times 2.1, scientific notation, 5 squared, plus 2 times 1.6, scientific notation, negative 11 times 150. Let's double check my typo. mv squared plus 2 qv, and then I'm going to divide that by the mass. Square root of that. You get 7.26 times 10 to the 6th. Yeah.
Yes.
If you got that full marks, by the way, I didn't give out the part mark breakdown for this question either. So for here, 1, 2, 3, almost 4 lines, I would probably go something like 1 mark for that, 1 mark for that, 1 mark for that, and then 1 mark for the answer. Here for 7 marks, 1, 2, okay, I would probably go 1 mark for that, 1 mark for that, 1 mark for that, that's 3, okay. 4, now this is too easy, too many marks. What was that, 1, 2, 3, 4? I guess 3 marks for, I don't know, something stupid like that. I'd have to figure out a better marking scheme. This to me is a little simple. Before we turn the page though, Spence, I would also have no problem giving you a final initial speed and saying find the voltage or find the charge. Okay, these are all different ways I can mix and match. Now, I can do exactly the same thing, except instead of for plates, I can have an electron moving towards a point charge or moving away from a point charge. Well, for energy now, we would have to use K, Q1, Q2 over R, and it was a bigger pain, a lot more data to enter. We started using ditto marks if it was a work question. I didn't do a work question on this. Can you give yourself a lovely score then out of 13, please?